In this video, I'm going to look at two techniques which we can use to detect outliers, namely the 3 sigma rule and the 3 mad rule. I'm going to start by defining exactly what an outlier is. Then I'll introduce these two methods to detect outliers, walk through them, we'll compare and contrast the results, and then we'll look at a couple of different ways in which we can present the results which we've calculated. As a starting point then, I'd like to define an outlier. An outlier is a data point which is significantly different from the central tendency. And remember, central tendency means either the mean, the mode, or the median value. It does not mean a data point which should be immediately deleted. Identifying a data point as an outlier means it's a point which requires further investigation. It may be a data point which is wrong, and then you can amend or delete depending on what you deem as most appropriate, or it may just be a typo or a data point which could be corrected, or it may be an accurate data point which is just different from the others, and then you need to investigate why. So remember, an outlier really means a point which requires further investigation before you progress. The data which I'm going to use is data from Mark Goss-Sampson's book, which is available on the JASP website. If you've seen the descriptive statistics video on this playlist, then you may recognize this data. It also would be helpful to view this because I'm going to use some techniques which I've already covered in that video, and so I'm not going to walk through all of the commands again. If you see anything unfamiliar, I encourage you to go and watch the descriptive statistics video, and I'll explain all of the commands I put into Excel to do this. There's a lot of data here, and to simplify this video and to avoid the screen becoming too congested, I'm only going to use the 3 variables in group 2, and I'm going to use these twice. So what I'm going to do is have the exact same variables, and then I'm going to apply the 3 sigma rule and the 3 mad rule to the same 3 variables. I've already input the means, the standard deviations based on a sample, and the median absolute deviations. So again, if you're not sure exactly what I've done here, then I encourage you to go and watch the descriptive statistics video when I walk through exactly what's happening in that command. Now, the 3 sigma rule is based on the fact that the sigma, Greek letter, is used to denote the standard deviation. And so what we're saying is that if a data point is more or less than 3 times the standard deviation added or subtracted to the mean value, then it warrants further investigation. And so we can do this quite simply once we've established what the mean and the standard deviation are, by just taking the mean value and then adding 3 times the standard deviation, and then taking the mean once again and subtracting 3 times the standard deviation. And to help visualize the difference between the two approaches, I'm just going to subtract the lower from the upper limits which I've just calculated on those 3 times. Now, the process for the 3 mad rule is exactly the same as the 3 sigma rule. It's just that we use medians rather than means and median absolute deviations rather than standard deviations. And if we just look at these differences as a starting point, then certainly we can see in variable 1 that the 3 sigma rule has a range of 1020, whereas the 3 mad rule has a range of just 243. And although the difference is less extreme, when we look at variables 2 and 3, in both cases the 3 mad rule has a smaller range than that of the 3 sigma rule. So we know that there is a greater probability of identifying outliers using the 3 mad rule. And this means that we've got a couple of considerations to think is when would we going to use which rule? Now, if we apply the rules that we've identified for generic descriptive statistics, we know that the 3 mad rule is a non-parametric approach. Therefore, if we have data which is not normally distributed, then this is our approach and we can't use a 3 sigma. However, if we have a normally distributed data set, we can use either the 3 sigma or the 3 mad rule, and then we need to decide how strict do we want our rule to be. If it's really important that anything that might warrant further investigation is identified, then we can opt for the 3 mad rule. If we don't need to be quite so strict in our assessment, then we can go with the 3 sigma rule, which is a perfectly valid approach. Now, once we've done this, The next thing we need to do is actually look for any number that's in our data set that's above an upper limit or below a lower limit. And just eyeballing the data, there's a risk you might miss something and it can be a little bit tiring. Now, luckily in Excel, there's a couple of ways we can do this. And the first thing we can do is we can use conditional formatting to tell Excel to change the color of any cell. Now, I've set this up already, and you can see that what I've asked Excel to do is identify any number that's above an upper limit and change that to a red color, and any number that's below a lower limit and change that to an orange color. Now, the 3 sigma rule thinks that variables 2 and 3 are absolutely fine, there's nothing of concern, and in variable 1 we have one data point which has been classed as an outlier. And this value here of 91.7, so it's perfectly feasible, that could actually be 917. So it's definitely a case to go back to our notes and have a look to see if that's a genuine outlier or not. The 3 mad rule, as we expected, has identified quite a few data points, both in above the range, above the upper limits, and below the lower limits. There's a couple of techniques that we could do to actually try and change this around. Once we've gone through, if it turns out that our value of 91.7 is wrong and we believe it's wrong, we can remove it. Now, if you look at the range, you'll see that doesn't actually change the range at all of the rest of the data set. It simply changes the position. It raises the upper threshold and it raises the lower threshold by equal amounts. This doesn't always happen, but it's worth bearing in mind that's not necessarily going to change the range of what you've got. It just means now there are no data points which are actually included and classed as an outlier. If I just took out that same data point in the data we're applying the 3 mad rule to, you can see we do get a change to our range here. However, if I take out all of the points, then we go back to where we were. One other point we need to be wary of is that sometimes if I go through and I delete a data point, you can see that another one appeared. Because when we change our upper limit and our lower limit, then sometimes that will mean that a new data point, which previously was not considered to be an outlier, is outside of the new upper limit and lower limit. So you need to be careful about how many times you're going to delete any data points within your range. As a rule of thumb, they say don't actually do more than 3 times. However, this is a rule of thumb and I don't have any reference to support that fact. Let's have a look at a visual way of representing these using figures. So this is a little bit busy. So what I've done here is I've put the 3 sigma rules, and this is variable 1, this is variable 2, and this is variable 3. So you can see that this dot here, which is underneath this line representing our lower limit, is representing this first variable with the data point 91.7. And in the variable 2 plot, you can see that there are no dots above the upper limit and no dots below the lower limit, and that means that everything's quite happy within there. Likewise, we've got no colored data points within variable 3 and no dots above and below. You can see that as the numbers increase, there is a tendency for them to start clustering down in a slightly lower portion. It's not as evenly distributed but within the data set, variables 1 and variables 2. If we look at the 3 mad rule, then we can see that as expected, when we've got a couple of data points above the threshold and a couple below, and we can certainly see that this data point here is affecting far more than any of these others. Let's have a look. If I take out this data point, we delete that, you can see we still have 1 below and 2 above. I could go through and delete those one at a time and say, well, now this is the furthest away now if I take this out, but it's still not making any real impact above. But it's nice to get a sense about how these are lying relative to the actual thresholds. So as we can see, the 3 sigma rule tends to produce a less strict assessment by having thresholds which are further apart than the 3 mad rule. Now, this doesn't mean that one test is more appropriate than the other. It's just a factor which you need to consider before you decide which test you'd like to use. If you have any comments or queries, please do place comments in the comments boxes below.